Good afternoon, everyone. In this video lecture, we'll be discussing the theory behind beam deflections and ang iyang computation din, ana. Okay? Now, first, before tayo delve on a topic, the reason why we need to think about deflections is that back in strength of materials, guys, got man ta ng strain, ba? Strain is also a function of deflection. Unsa ang kuan niya? Amount of elongation, deflection rather, deformation, in which atong quantify din ang change sa iyahang kuan geometry unsa siya kadako. Now, deformations will result in sana stresses pod, diba? When you say stress that is caused by force, deformations are caused by force pod. Therefore, musturya sa deflection. Deflection is also another term for deformation, although laylay lang siya direction. Okay? When you say deformation man good, let's say sa atong understanding from strength of materials, bitad siya one direction lang siya. In coordination kung atong force dito, our deformation is like this. Now, when you say kung ano po din diri, deflection, yang dito, ang direction na sad sa atuang kuan will be something like this na pod. Okay? So, in other words, more siya kanang lateral na kuan dani, lateral na deformation when we talk about deflections. Now, this afternoon we will be deriving some expressions on how to quantify ani siya tong mga beam deflections. Okay? This is also a very good parameter sa atong design. Now, let's take this figure for example. We have a cantilever beam na supposedly ang original niya na kuan shape na lang siya straight. Then we impose a deformation or rather a deflection in which mo deflect na siya dito pa isa nga na way. Okay? Now magkuan ko na siya ha. Let's say start from atong referencing diri. Ano siya atong origin. Now, we take a very particular point sa tuwang beam. We will just label this as the elastic curve. Ato i-define ang geometry sa tuwang beam in terms sa atong elastic curve diri. Ito siya itawag na elastic curve. Now, initially, siya, nabinat din siya, naingana dayon. Okay? Now, for this point diri, correspondingly, ganun siya point, nani siya slope. Okay? Na siya x, na siya y coordinate, and also nasa siya slope. Now, what is our definition for slope gani? As far as we can remember diri, when you say slope, that is rise over run. Okay? That is rise over run, kung istorya tag slope. Now, from this slope dayon, let's go back to this. Ngano naman siya mga additional drawings lagi diri sir? Kani siya mura r or rather radius dinhi kaning rho. That is actually the radius of curvature, okay? I hope makita pa na siya dana. Radius of curvature ni siya. Rather, okay? So, biya ko lang isulat diri. Radius of curvature. Okay? So, that is the radius of curvature. Now, sa tuwang kuan ni siya imagine that this kaning red na strip din this is a part sa tuwang beam dito. But let's try to examine this on an infinitesimally small na level. Okay? So, this is actually can be reduced into a strip din Unya, kung musturya kay taganang siya kanang curve gani mo, curvature gani na siya, diri, we can quantify curves as objects of a circle. Ba? Yung circles, makakuan man ta ng circle na. So, when you say na ingon kaning curvature gani siya ato siyang i-practice as mura siya ganang part sa circle, it is circular geometry directly applies na dayon. Okay? Although on a very small na level. Now, that's the fun part sa to kung mag-calculus ta kay we can use assumptions na din na safely as long as ato siyang gi-take into account ng unsa kadako yang geometry. Now, ang curve anin siya din yan, pag piko niya paingon dito, gamay man kay na siya sa ngatanan. Okay? So, kung gamay kay na siya diri, and if kato din gi-mention o ganiya, curve siya, ato siya imagine na part siya sa circle, then therefore, we can have, radius, ba? Muna siyang ga-define sa radius of curvature. I think this was better discussed in yung analytic geometry. But this is where, kanato diri, ang curvature niya. Now, when you say curvature gani, again, circular geometry applies. This is a angle. But in that case, gabi kina siya gamay na angle. Okay? Pero atosa na siyang pangitag way na mo kanda ni mo reflect siya. And of course, kanisan siya diri, gamay kini siya na kuan na circular arc. So, I'll just call this as ds. Okay? Now, at this point na sa dayon, natay ka na mga small changes diri sa yaha. Okay? Now, from here, paingon din ni sa kanina point, I'd like to label this as dy. Okay? Now, ang horizontal na sa dinanan niya nakuan, igagmay kasi ng movement dito, I'll say that is dx na pod. Now, natay dy, natay xy, natay theta. Okay? So, if this is theta kayang rise over run sa itong tangent line to the curve at this particular point. So, therefore, napo ni siya change in theta pod. Okay? I'll just call this d theta. Kani siya diri. Now, if this is d theta, pag akuha ni siyang ikuha kani siya strip din niya, akuha na siya na dito. Or, you can prove it via trigonometry. Eventually, may mo ni siya diri, we'll come to the conclusion that this is actually equal to theta gyapon, d theta rather. Okay? So if that is d theta in kuan diri, we can now derive for sana uban ng mga kuan ani sa yaha. Stuff. Pwede natin siya makuan diri, maka-derive tag mga expressions na pod. Okay. Now, from this figure dayon, let's try to derive some expressions ani sa yaha. Okay? This is part of a small isa ka kwan, circle kani siya nga atong kwan dinhi set up natay ds, natay d theta, and we have rho. So, we can just say lang din dari na we have ds is equal to rho times d theta. I think this is quite familiar sa inyo trigonometry sa una, ba? If we ignore the differentials, we will have niya kanina siya change na to r. That is actually the arc length sa itong circular segment. Now, as such din ana, mustura tag arc length na pudsad, we have ds, we have dx, and we have dy. Now, we're playing with very small numbers diri. Why not we as kani si ds atong previous na description na siya, that is curved. Ba? But since that is very small, okay, we're taking this into an infinitesimally small na level, why not we try to assume that ds is actually a straight line that connects these both points, ang yung behavior. Total, gamay man kay siya. That is the fun part ani sa ang calculus. Pwede na siya madula-dula. So, if that is a very small na number diri, and I can assume that this is perpendicular na diri atong dx ug dy, and this is ds, what do we have? A right triangle. Right triangle geometry na din, thus applies na sa tuang situation diri. So, we could just say lang din dara na unsa. ds squared is actually equal to dy squared plus dx squared, ba? Pythagorean theorem. Now, ako ni siya dula-dulaon na sa dayon, I divide everything by dx, so I will have ni siya is equal to plus 1. Ba? Ako ni siyang i-factor out ang kwan. Squared. This is unsa. Okay, ako ni siyang tanggalon diri. Plus 1, and I apply the square root ani siya, and I will have this expression na sad. Ba? So we have something like this naman sa dayon. Okay, so much for those expressions na itong na-find dito sa itong figure. Now, nasa line ko andari, concern. Let's try to define what is slope, ba? Definition of slope. Let's just take this to heart. Unsa ni siya? Definition of slope. Now, when you say slope diri, that is actually unsa? Rise over run, ba? Sa tuwa sa kuan dito, sa ito siya? Sa tuwang panahon sa analytic geometry. Okay? Now, kaning theta din diri atong tanaw na pud, ba? That is the angle sa iyahang kuan nga face siya, rise over run, ba? Nasikon din ni. Mura gyapon siya og kuan. You say slope, kani siyang atong kuan diri, that is slope. Rise siya diri, nya run pagid siya sa ingon ana, ba? This is y, this is x, and this is theta, ba? So that is our rise over run din ni. Now, M man atong previous notation na ni siya, but ayan bagong form na sa din diri when you talk about beams na pod. Theta ang atong form diri. Now, you say rise over run na po din na siya, ayan na sang movement na dayon. Gikan sa kuan diri, ana siya, horizontal, o pasaka po dayon. So, when you say movement na sa dana siya, yung pagsaka gani, rise niya, change in verticality niya. So, when you say rise niya, change in verticality, that is dy. Okay? Y is just unsa na kayang point lang. But when you say change gani in kuan niya position, you have to consider the differentials. Now, if that is dy, therefore this is unsa? Dx po din siya, ba? Rise over run, rise over run. Nidagan siya by how much? Dx. Ni-rise siya by how much? Dy. That is our definition for slope. Now, further playing with this equation na sa dendiri, ako ni siyang i-grab. Ako siya butang dendiri. Now, before sa tamad to dana, let's try to talk about angles. Very, very small angles diri. Okay? If tanaw na ko ni siya din now, usually, if mo tanaw mo mga beams, dili niyo na siya mapansin diretso ang kuan. Ang iyahang mga deformations ba? Deflection niya. Dili talaga sa kay bihira na gyud makita kuan gabawg na beam. Now, if makita ka ng beam na gabawg sad, that means ikaw makulbaan ka, ba? Why is that very unusual? Kaya dili man na usually makita ang gabawg ang atong beam. If our deflection sa beam diri is becoming very evident na kanang to the point na makita na gina siya, very obvious na siya, then kuan na gina siya, dako na gina siya ang problema, ba? So in other words, ang normal na deflection sa tuang beam kay gagmay kay gina siya sa tanan, ba? So when you say very small na gaya niya, infinitesimally small, we're dealing with very small angles diri. And there's a kuan na kanang trigonometric relationship na becomes valid na dayon, ba? What is previously invalid sa atong mga dagko na mga numbers becomes very valid na din diri. Now, say, kani siya like this trigonometric function, tangent theta. Butang kag theta diri gamay kay sa tanan niya, it is almost approximately equal to the angle itself. Okay? You can grab a calculator, set it to radians, and you can try 0.001, and most likely, kani siya 0.001, gyapon na magawa sa na siya. So if, you can try to experiment on that. Now, if that is the case here, I can assume na dahil na kani siya should be equal to kini. Total gagmay mo kayong mga angles. Our assumption is valid. So, we have something like this. Natin una niya klaseng expression. Okay? Now, I will try to differentiate this and I will have unsa second squared theta, and this is unsa. We're differentiating this with respect to x. So this is d theta dx, and this is unsa na pod second derivative na pod sa y with respect to x. So this becomes kanya tong expression. Now, from trigonometry na sa dendry, kaning second na squared theta, that is actually equal to 1 plus tangent squared theta. So, ako na sa siyang dula-dula na po din. Tangent is actually equal to unsa dy dx. So, this is unsa dy dx squared, rather. So, ako na siya i-connect din eh. Ako siya i-substitute and I will have unsa d theta dx ko na din siya multiplied by ako siya ilabay ito sa kwan. I will have a expression terms of kwan and isaya second derivative and isaya din there of y with respect to x, and this is unsa 1 plus dy dx squared. I have these equations na po dayon. Okay? Now, gusto na ko ni siya dula-dulaon na po dayon. Okay? I'll just call this equation 1, call this equation 2, and equation 3 na po dayon. Let's try to combine these terms daw ko na and play with them. Okay, so this time na sa dayon, ato na sa siyang tanawon. Ba? We have exactly tulo ka buok klaseng expressions diri that come together to form yung sa murag masyada na relation diri, ba? Let's try to figure this out na sad. Let's play with them. We have equation 1, 2, and 3. So, I would like to play with equation 1 first. I have ds is equal to kani siyang rho times kanadayon, ba? Now, I'll just divide everything by dx dayon diri. What happens na sa din ingana na din siya. It will take this kind of form. Now, we have expression for this and we have expression for this na sad, ba? Try and substitute na pod. Now, I have kani siya diri, this is square root. So, when you say square root, gani siya 1 half. Ako na siya i-rearrange diri, pumanay dautan. So, ako siyang butin diri 1 plus dy dx squared 1 half. Okay? So, muna siya itong expression for that. Now, kanina sa din nga itong kwan diri, ana lang siya. Ba? Relax lang. Now, kanina siyang other na po na point diri, kaning si d theta times kani. That is d squared y dx squared, or second derivative na siya. Okay, I hope maklaro pagyapon na ninyo. Now, we have this expression na sa dendiri. Now, let's try to simplify na po dayon. Okay, this is power of 1 na siya. Kani siya plus times kaning 1 half. Now, ako na sa kwan diri, kini. Ako na siya labay dito, and ako na siya divide diri. So, this essentially becomes three to the power of 2, ba? 1 half plus 1, that is 3 halves. Now, I'll divide this by unsa. Kani ang derivative na po dayon. Okay? So, we arrive at the following expression din eh. This is how you derive the insana ka na radius of curvature. And expressions niya in terms of calculus. Gets? Although, ato ni siya magamit karon once konta maka-find na sa tagline expression na po na sa iya ha. Okay? Now, di na to siya readily magamit sa nga na form. Gusto na ko siya dula-dulaon. So, I'll just say 1 over rho that is equal to the reciprocal aning atong kwan diri. So, this is the second derivative na siya. 1 plus dy dx power of 2. This is unsa. This expression na din atong kwan testing ro gamit sa next part sa tong derivation. Okay. So ato to siyang i-take note katong last expression na itong na-derive which is kini. And then we borrow a very familiar na kwan expression from strength of materials. Okay? I think kani siya din this is what we call the moment curvature relationship niya. Okay? In which we have EI diri that corresponds to unsa flexural klaro ang red. Okay? Flexural rigidity sa tuang beam. So, ang inherent geometric properties din niya o ganang homogeneity na dayon, it comes to play na din sa tuang kaning flexural rigidity. Diyan na siya ma-take into account. Now, anyway, we have the moment curvature relationship plus kanida yun. Ato siya substitute and let's try to see what happens na dayon. Okay? So, I substitute this with this. One plus okay. So, nating na niya klaseng expression na pod. Now, unsa atong gina-play diri na klaseng equation ba? Natin siya mga differentials diri, na siya mga derivatives, ha? Ba? So, essentially this is a differential equation. Now, with differential equations ani na siya mga dy dx mga nana, ba? Na akong gusto makunan diri kay i-recall na to unsa tong kuan na to slope ganiya, ba? Slope is unsa? Biya akong gamiton, let's try gamiton na to ning blue. Slope is equal to dy over dx. Rise over run. So, unsaon niya pagsaka diri unsaon pagkuan nito ang dagan sa niya, ba? Take note that we're playing with very small numbers here, ba? We're playing with very small numbers din. So, we have to note that this term here, dy dx, is very small. Very small. Okay? Very small. So, gamay kayo siya sa nga tanan na number. If natay gamay kayo na number, niya, tuwa din siya ikuan din, square na to siya, raised to the power of 2, what happens na nasa iya, ha? Ba? So, you say 1 over 10. 1 over 10 raised to the power of 2. What becomes of 1 over 10? 1 over 100. Ba? So, you say 1 over 1,000 times 1 over 1,000, in other words, 1 over 1,000 squared is very, very small. 0.006. Ana. Okay? So, 1 over 1,000 squared. So, 1 over 1 million. So, that is very small. That is very, very, very close to 0. So, you could just say din diri, para natin ka ng approximation sa nisaya, why not just assume that dy dx is 0? Kani siya na term, rather. Ba? So this simplifies na din. This is the beauty with calculus din dari. You can assume very kuan din. Na kay mga assumptions dagan kay mahimo dari. So this is essentially 1 plus 0 raised to the power of 3 halves. 1 raised to the power of 3 halves is still 1. So we have this. Natin nga niya klase expression dayon. Okay? Okay. Let's try to derive the expression for slope na sad, ba? Slope sa daw ko na ta. Now, we have this. I would like to grab this and see how this goes lugar. It's equal to m. M, by the way, is moment. Okay? So, natin nga niya klaseng expression siya. Ha? Now, this is the second derivative. What happens to a second derivative if ito siya integrate? Sa may tabo siya, becomes a derivative. Okay? So, first derivative. So, ato ring moment sa dendere, this is also a function of x. Ba? Putol sa gamay. One of the reasons why ako ata mong gipakwanda ni na-review ta atong shear and moment diagrams back sa to ang first lesson kay para makwanda makita ninyo na moment is a function of x. Okay? So nasa function of x na siya. X na kaniya itong gigamit diri na horizontal coordinate niya, ba? So in that case dayon diri kani siya function ma-part na din siya sa integration, ba? When you say integration gani, if wala gani siya variable, pwede na siya factor out. But if in the case lugar na m can be a function of x, then it becomes a part of the integrand na dayon. Okay? So, with that in mind, ito ang moment diri, makuha na siya, mapil siya sa integration. So, I would like to integrate this. Ba? This becomes unsa? This is okay? Or, if gusto ninyo na mas kuhan gamay diri, slightly more mathematical, I can say din dara na, butang og integral diri, okay? Okay, akong kikon man siya, via calculus. We differentiate the first derivative. We will have the second derivative. Okay? So, muna siya kung siyang game mga replacement nga ni. Okay? Wala man siya dx na differential. Okay? So, ano na din siya din eh. Dx. Okay? So, ako na siyang kondon eh. Both operations cancel out. So, ako makuha diri, dy dx is equal to the integral of m over ei dx. Okay? And whenever we say integrants gani dayon, kunya wala siya kanang kuan diri, definite na limits. This is not a definite integral na dayon. It is an indefinite integral. We add the corresponding kuan dani kanang sana arbitrary constant niya, which is c. Gets? So, kani din siya diri, ako na siya further simplify. This looks very familiar, ba? This is equal to slope. So, we have an expression for slope diri in terms of m. This is slope. Okay? Okay, so therefore, when I'm going to say slope, let's talk about deflection na pod. I got this expression gikan adtong sa tuwa diri ganiya ba? So, ako na siya ikuan diri, i-move na ko na siya dinhi and I will have unsa dy dx is equal to the integral of so natin nga na expression. Ako ni siyang i-integrate na po dayon, ba? If we integrate this, then makuha na to si kuan, ba? So, this is just essentially, sige na lang, can go with sinasad ng differentials. So, m over ei dx plus c1, I multiply this by differentials niya, ba? So, I add integral diri, and dun sa na din siya. Wala, makuha natin si ikuan kini. Kani siya integral plus integral, so we have a double integral. Di siya double integral na kuha na multi-variable calculus. This is a kuha na siya ka na one-dimensional calculus lang tani siya diri. But, essentially, kadua lang siya integrate. Okay? So, integrate na ko ni siya once, that is unsa, plus x na din siya. Ba? Basta constant. Now, kani siya diri, na naman sa integration process, this will result into a second arbitrary constant, C2. And thus, we arrive at the expression na itong ipangita diri for beam deflection. Okay? In which C1 and C2 are arbitrary constants. Okay? If you have questions regarding sa akong lecture din karon, feel free to ask me. You can comment them sa akong post later on, or you can send me a message. Okay? Comments and clarifications or questions. Okay? I welcome them. Thank you for listening.